you and Gabe. So anyways, this is the primary interview process. The purpose of these interviews is to check up on each of the subsystems to make sure that there are no holes in their research and early design within the model-based design timeline. Today we're with the ground station team lead, Anderson.
How you doing? I'm the ground station team lead, and I'm going to talk about what we've been doing the last few months. Start off, this team is working on both the ground station and the communication because they're so intertwined. And objectives, just to keep it rather simple, is mission control and monitoring. And we start off by just setting up the ground station. Right now, we just have a skeleton, just so we can learn the basics of it all, and just how to read data, how to collect data. We have some examples I'm going to show later on. And along with that, we're going to I'm in the process right now of learning how to decode the data, which it's a bit difficult and it's a bit of a learning curve, but it's doable, and we're all in the process of learning that in my team. And then once we have the satellite up and running, our main objective and goals is just to keep track of it using other ground stations and receive data packets and waterfall streams just to collect all the data and whatnot for the experiment. So we have a rough outline of the ground station equipment that we're going to need, and along with that, I also made a priority list of what we need ASAP and what we need later on, and stuff that we can kind of put a little bit less money into, and stuff that we can put more money into. So as of right now, we just have a skeleton, which is just the antenna, which is a dipole antenna using VHF frequency, and a RTL SDR kit, and we're running that on a Raspberry Pi 3. So we're able to just collect data from other satellites flying over, but it's kind of rough to collect it because we don't have the best location, because we just have putting on the ground because rooftop access is hard to find in Florida, especially with the rain and whatnot, and the pretty bad weather recently. But we can be able to collect a little bit of data here and there. Here I have a list of the costs, and I made two different lists with different equipment. Some of it is not as high quality because the thing with the ground station, we don't have to buy everything right away. Like we can skimp out on some things here and there to then add on more later when we have more funding and whatnot. So for the first list here, we have the kind of like the wish list that we all want, that we can read through the SatNav site of the network and different forms and whatnot, and just kind of researching on the web. And here's kind of like the more laid back version where we're stimping out a few things here and there that we could then add on to later, or just kind of keep low key until we need it for future experiments. And then with the communication side of things, we need to set up a communication system on the SatNav itself, and this is where we want to spend most of the funding for our team, our group, our substation rather, because this once it leaves is gone. So we have been looking at either building a satellite antenna or getting one of these from the one of the sites online. And these are kind of expensive, being around $3,000 to $4,000. But this is the antenna release system, and the way that these work, they have a thin metal wire that is then burned using a high amount of heat from the battery right after it's launched and all that. But we have to communicate with the power supply team to make sure that we have enough power and juice to burn it out so they can open. And then we could also build one ourselves. It's not that difficult of a design, but if possible, I think it would be preferred to have a professional made one. And we also like if we were going to build it ourselves, we have to have someone that has access to a 3D printer and knows how to build stuff on there, or we can do it. It's going to take some time, but it's feasible. And the main part, like we can't really do much ourselves, is buying a UHF transceiver, and this is like the main form of communication of how we talk to the satellite up there. So that is going to push us back around. What was it? Like $3 or $4 grand, I think. And then this is where we want to put most of our money when it comes to this team in particular, because everything else we're going to head on to more later. And for what we've already gotten from the SatNav network, we have this is one of our first kind of legible data dumps that we received. This is the waterfall right here. This is not anything from space. I don't, from what I've read about, this is just some local noise, and because we don't really have like that good of a location yet, but we're working on that right now with the experimental team setting up a wow factor security library rooftop at the university. And with that, I want to show some of the data we've collected. This one, you can kind of see it's like a tangent line, and all of these are usually local noise, but we can't really tell yet. And the decoding bit, I'm still trying to learn that because it's a bit complicated. And we are using a system from the SatNav forms and something called GR SatNav, which is a decoder, and also this other decoder called Tai, where we have to pretty much break it down using some references here on these other sites. And I was in the process of doing this one, but it was getting a bit complicated for me at the time. So I had some other references and whatnot, but give it a few weeks and we should all be able to figure it out. And then if you want to see a good example of what we should be having once we actually have the SatNav up running well, we're going to have something hopefully more like this with the audio and the transmission there, as you can see there. And because right now we're having mostly just these, which is just local noise and nothing in particular interesting to us, but we're going to start decoding this soon to see if maybe there's more than just local noise and we can get through all the static. And in some future, like some current objectives we're working on right now, is just the wow factor, setting up the 3D prototype and the display to secure the rooftop of our library. The team is working on an efficient new way to decode and learn the ins and outs of the Tai software. And we're all studying four of us are studying to take the exams for require licensing. And we're thinking about making either a website for the wow factor, and if not that, we're probably going to start working on the basic rough draft of the 3D printer and kind of release system. And we're also trying to find some sponsorship and donations to try to get some of the money built up to help fund the research team. And that's pretty much all we're working on right now that I can think of at the moment. But each person's kind of doing their own thing. Then when we have our meetings, everybody kind of brings up some stuff that they talked about or noticed or things that they're working on. So yeah, now I can do some questions.
Yeah. So you mentioned about the radio frequency licensing and understanding that data. When you take your exam, did they mention anything about understanding that kind of data? I saw they call it a waterfall. Was there any information on?
Yeah.
Did they teach you about how to read those?
We haven't taken the exam yet, but I'm not too sure. I think it's just going to be more on if you understand how to communicate with it without messing with other satellites. But I'm sure we're gonna reference something about that. It's not super complicated to look at and read, but it's pretty much useless without the decoding. Because all you're just looking at is the image, like some lines on it or something like that. So you have to decode it to actually get something valid out of the waterfall, the whether that's just static.
Okay. Another question I had is, I know we were talking the other night about, the differences between getting an amateur radio license and then NASA saying that it's highly recommended for us to get an experimental license. Did you look into which one your team should get, or does it really matter?
I think we should do both, because the difference is all we have to do is get one license and then we have to apply. If we get the amateur radio license, we can apply for the experimental and license. Then we don't have to take another exam per se. All we have to do is apply for it because we're under university and with the amateur. And if anybody has interest, which I know some people in my group do have interest, they want to have their own setups. Like Sasha, for example, she wants to do more than just collect some data in her ground station that she has right now. And Christopher was rather interested in doing more radio. So they want to do the amateur for that, for personal reasons, and also because it could be rather useful when we do our university projects and future experiments and whatnot.
Gotcha. Okay. Another question I had is, if you go back to your cost, your two graphs that you had for the ideal and the economical approach, your overhead was a very specific number. How did you calculate both of those?
For 5%?
Yeah.
It's just 5% of all this. Probably from taxes or out of state or whatever. Yeah.
Okay, so the $1,000 for the mounting hardware. Was that kind of like? Is that like just an estimate?
Yeah, that was kind of a shot in the dark because we don't know if there's any mounting hardware already set up on top of the library. Because if there is, from old unused equipment, we could kind of scavenge that, at least from some other building. So we can probably bring that down to much less than $1,000, just kind of a really, really high estimate. But I don't think it's gonna be that high.
Okay, that's good.
Yeah, because we wanted to set a number just in case, and that's also just in case if some of the other stuff is a little more expensive for either sold out or something like that. We have to buy different things, so it's not a good fit or something like that.
Okay. Another thing too is you have two different radios. One is 1500 and one is 1200, and they're both from different companies. Have you gotten to look at page 72 of the CubeSat document?
Yeah.
Okay. Do you know if both of those radios meet up to the specific requirements that NASA requests that the radios meet?
Let's see. So page 72.
Page 72. Yeah, there's a list. There's a list of, I think it's 10. No, a list of 8 items that the radios have to meet for requirements to be acceptable by NASA. Do you know if both of those radios?
I know this one does meet it because this one I actually found on the SatNet website itself, and this one I found relative to the with similar specs to the more expensive one, but it was a wee bit smaller and there's just a few discrepancies that were slightly different, but I'll look into it just to make sure and double check. And if not, this is alternative where we can change anything at any given moment until we have to actually have to purchase it. So I'll double check to make sure, but I picked the one that was closest in similarities to the really good one. Because I think this one was just like an older model or something like that, but I will double check to make sure.
Okay. Two more questions on this page. You have different antennas and different Azel rotors. For the antennas, what's the defining factor between that cost? That's a couple $100 there. Is it who makes it, or is it the transceiver level of the antennas?
I think it's a bit of both because this one it seemed like it was a bit higher quality um, compared to this one, and it was slightly larger too, so I think it might have a better range.
Okay. But if your
And
radios are comparable, and they're almost kind of similar in cost, and then I look at your antennas and there's like a $400 difference in there, I'm kind of tempted to just say, what's wrong with the XBot antennas if the other ones are $600? If they're comparable, shouldn't we just go with the XBot antennas, or is there something really defining about the $640 ones?
the 175 X quad, the frequency it doesn't have as good of a range as the M2 Leo, but it still fits within the ranges of a majority of CubeSats, and we can always. That was more for like just in case we don't have enough money, because these are like the top most important things, and that was just like a just in case if our budget is not really we're hoping for. That was kind of the best we can do for the lowest price.
Okay. And then the Azel rotors, I do see a little bit of a price difference there as well. Do you know if we can set up our own kind of Azel motor system with our antenna? I mean, because it's just the pointing accuracy of the antenna, really. I
Yeah,
mean,
well, with the antennas, there's actually two different types, like two main types rather. There's the uh, rotable, the ones that move and the ones that don't move, right? So the ones that don't move have obviously a smaller cone, and they're usually facing either straight up or at one angle. And if we're going to do something like that, which would be even cheaper than the X Quad, um, it would only have probably like a 60 degree angle facing directly in one direction and not moving at all. And if we have the rotor, we can move it in an X and Y axis, and we could follow something from the horizon all the way through the other horizon and get the most amount of data. So,
so what's the difference between both of those rotors?
one of them was kind of more of a name brand, and it had a bit more security to it, but and the other one's a little bit more not skeletonized, but almost bare bones. It was more of an introductory rotor.
Okay.
So it was
Okay.
kind of a thing that if we needed to spend a little less money on at the moment, and we can always buy a better one later, I was kind of taking out of there because everything else I couldn't really find a cheaper alternative because it was just everything was so similarly priced, or just was priced even more on different sites. So I just had to find where I could pull out money that we can replace later because it's not so deeply integrated into the machine that we can't pull out later. You know what I'm saying?
Okay. Okay, gotcha. Another one on the CubeSat side of the ground station, the antenna. I know we talked back with Willem Van Dam about building our own antenna. You had mentioned
Yeah.
that it is feasible. I mean, now we're trying to get partnerships with like Proto Labs and other printing companies. Do you think it's going to be cheaper if we build our own
Oh,
antenna?
most definitely. Oh yeah, because these are like for the one with the this one's 3,750, and this one's about $4,500 for the solar panels. And I know we can build it cheaper, and I prefer to do that because would be more us, like more us involved because we're buying outright out of different companies. It's not super difficult because all we have to do is the wire here. These wires are twirled up in these holes right here, and it's held down by a thin metal wire that is then burned using a high amount of using resistors and a high amount of heat from the battery right after it's released into the into orbit. So if we can pretty much, we can definitely find some schematics online where we can use those as an example, or we could just do our measurements ourselves and build our own, because it doesn't take that much to build this. But the only thing we have to do is do some 3D printing software, and someone doesn't know already, one of us has to learn it. It probably wouldn't be that bad. So
Okay.
I prefer to build our own.
Go ahead.
And then I prefer to build our own, because it'll be much cheaper. And we could also try different methods and different ways of kind of putting it together, and it can be more suited to what we need instead of having our CubeSat fit this. You know what I'm saying?
Yeah. So that's definitely going to be something that will need to be solved quickly. Like if you can solve that within the next week, that would be great. The reason being is because I remember we looked at these. These are EnduroSat antennas, right?
Yeah.
Yeah, they're expensive,
Very
and
expensive.
whether if we can build our own, the reason it's got to be done in the next week is because we have to prove to NASA a reasoning why we built our own, rather than it was just cheaper. Because NASA's not going to care about the cost; they're going to care about, does it work compared to what's on the market. So if you guys can do some research in the next 7 days and come back with me saying like, no, we just can't build it to the same level of specs as we need. We have to buy, and because if you guys don't figure that out, we find out that we can build it on our own, but we just didn't take the time to do the research. Well, we just lost another $4,000, which is going to really suck. So if you guys can come up with at least a definitive answer by the next 5 to 7 days of, yes, we can build our own. Here's everything we need to do to build our own. This is the level of testing we have to send it through. And if that's the more cost-effective solution, please solve it, because that's going to be another $4,000 we have to try to chum up in the middle of a virus. And that could be grounds for a countdown halt, or grounds for an extra year that we have to wait to receive more funding. So that's definitely a mission killer if you guys can't figure that out in the next week.
Okay, so I can definitely have some type of like an outline or like a blueprint of what we should do, but I don't think we're gonna have an actual like 3D printed model ready. I don't know if that's what you're asking for, because we can definitely have like just the blueprints of how we would have it done, and we're not gonna have the actual like model just yet.
Okay, I mean, if you can just gather a bunch of research about what other university CubeSat's done, try to get in contact with them and that built their own, and say,
I made some
hey,
contacts with them already.
okay, yeah, just call them and just start a conversation going with as many other pre-launched, in-house developed antennas, and see the feasibility. And you don't need a 3D model, yeah, obviously by next week. If you can find one online that's going to work for us, I mean, by all means, like, yeah, that would be great. But just start talking to them, because, like I said, that's another $4,000 that I can't really guarantee we can just get, because looking at your other slide, we already have $6,000 or $4,000 for the ground. That's just on average about, okay, assuming the mounting hardware is only like $500. Okay, you're talking like $5,500 or $4,000, right? Just for the ground side, not including all the transceiver and everything else that's going to be on the satellite. So you're already talking.
If we did go cheaper, we could do, just for now, until coronavirus goes away, and if it goes away, and we start building up some more money, we could do one of the non-movable ones, the just bipolar omnidirectional antenna that will just point in one direction, or we can collect data from whenever satellites heading over that certain point. But it's going to be a lot less efficient to collect
Right.
data from our satellite and others, but it'll be something that we can do until we have the funds to handle it.
I personally agree with you on having an ASL rotor. I think that it's going to be way better for connectivity purposes than an omnidirectional.
Yeah.
And I definitely agree with you that. And I know a lot of other CubeSats, we've seen them. They do have that pointing ability, which I think is definitely more beneficial. So
Yeah.
that leads me to my next question. What can we do right now to get your team up to speed and caught up? Because I know that we haven't really been too much in contact with you. So I just want to know, what is it that we can do as officers to give you the resources that you need to kind of get this ground station, kind of leaps and bounds ahead of where we're at right now. You're at a good spot, but I just want to know, what is it that we can do in the next coming weeks, mainly in the next 20 days, to get your team where they want to go? What are the ideal conditions that we can get for you?
Well, like the biggest thing that we could have right now is some money to buy some of this stuff,
Okay.
but I don't think that's going to be feasible in this time. So we're trying to get roof access again in one of the neighborhoods in someone's house in our team. So if you know anybody who has a high roof, like that lives in an apartment or something like that, we could try to use that to collect some better data and get a bit more head on the decoding and just kind of knowing how to work the software a bit more, the CubeSat software. That would be nice because there's only so many people on our team. A lot of people don't have roof access. For me, I have a giant bush area right behind my house, and my roof isn't really accessible at all. So if we can do that, once school starts back up, hopefully we'll be able to get some type of roof access at either engineering west or engineering east until we have a definitive answer on the library. And hopefully, if we can get the library outright, then we'll be setting it up there, and we can just remotely access it and collect a lot more clear data from other satellites.
Okay. And we're going to be getting, probably tomorrow or today, I might kind of nag the professor that we're working with to get us software where I'll send you the YouTube video on how to do it, but you can actually put a ground station on the actual elevation of the library in this software we're going to get called AGI. So you can put a ground station, zoom into the Bing Maps 3D version, click on the library's roof, enter the elevation of the roof, and then add a ground station to it with all of your specs that you have for your transmitter. And you can add the ASL mask is what it's called. And basically what that does is it scans the nearby area based on the 3D maps, and it tells you where you're going to be impeded for your radio communication. So what it'll do is it'll add, depending on how far your cone goes, whether it's a 360-degree transmitter or if it's just a 90-degree transmitter or a 180-degree transmitter, you'll be able to add that in there. And then what it'll do is, based on the elevation and the location of where it is in reference to everything else around it, it'll tell you what's going to block it and where you can actually communicate it as it's going overhead. And it'll come up as a three-dimensional simulated, kind of rigid broken circle around your ground station. And then you can also tell it the range of your transmitter. So it'll create, a kind of a dome of, from your ground station site all the way up to the level of transmission that your ground station goes. And then when we add in the satellite, depending on the orbit or the inclination of the orbit, the software will actually tell you the amount of times and duration that you will actually be able to contact the satellite. So it'll show you every single point in time and at what degree and direction the satellite's going to pass through your arc of transmitter data. And you'll be able to log that, mark that down, and have that as an actual report generated by the software and keep that with you and kind of mark it on your calendar. So I'm going to kind of nag her today, but the reason that's important is because 30% of our proposal is a feasibility review, where the feasibility review is it's an investigation conducted by a team not part of the project. So we would contact a professor or another student club or something like that, and they have to review the technical implementation, including feasibility, resiliency, risk, and the probability of success. It should be comprised of individuals not on the project team, and it's weighed 30% in our evaluation for NASA's selection. So the reason I ask is what can we get you right now is because this is the big one. As I was reading to you the other day in the CubeSat 101 document, they say you should have the ground station first. If not, just grab stuff from the radio club and start setting it up as soon as possible. And this is going to be one of the first things that they're going to look at, as well as the ADCS team, is going to be can the satellite point and can you communicate with it? And then after that is the payload, the microcontroller, and stuff like that. But those are the two main things: ADCS and ground station. So if you guys can find some way to just you have that priority list there. If you can find a way that you can subvert that cost and still achieve, communication with CubeSats and start understanding the software that way, set that up and let me know of those things. And we're going to spend the initial part of our budget on the ground station so you guys can get going, because we have to send this in, no later than November 4th, I think it is. And when school kicks in, it's definitely going to be crazy. So, we got to make sure that you guys are squared away and ready to go. So the main things you guys got to start working on are antenna, building that in-house, and using your priority list and finding out the cheapest way that you can start communicating with satellites right now and setting up the ground station and understanding the software and getting that licensing, which you guys seem to be pretty, for the most part, on track. But the next 20 days are going to be very, very, very crucial to this success of sending in the proposal and getting approval by NASA. So you guys have a pretty busy next 20 days, and especially for us on our end, because we're going to try to get you that funding.
Okay. What were you saying before about the 30%, and we have to have like readable access to our satellite on the CubeSat network, and there's a SatNav network rather. I don't know if anybody has shown you this yet, but you can actually access other ground stations all around the world, and we could track. Once we have the satellite up and running, you can actually track where it's going to be at any given point. And it'll tell you like if it's going to be flying over one specific area. Like here, for example, is the one at Sasha's house.
Yeah, that's perfect, because what we'll be able to do is use the software report generated from AGI, as well as our actual ground station reported on SatNogs and the other ground stations, and compare the data and detect the desired versus the actual.
Yeah, the only issue is, if anything is ever drifting or if going off course, like we can have to calculate for that. But like once our satellite's up in the air, you can actually pass prediction, and you could schedule stuff, and it will automatically collect the data from the satellite as it's flying over, if it's flying over. And if not us, we can always get it from a different ground station somewhere else in the world.
Perfect. Okay. Well, what does Sasha have at her house right now? Do you have an equipment list of what's on her ground station?
I actually have. She literally just has this, which is a an all-in-one beginner kit, which is the antenna right here, the RTO SDR. Basically, this is like a little chip that can collect all the data, and then she connected that into her Raspberry Pi, and she's been running the software because it doesn't take that much processing power in the Raspberry Pi 3 is more than enough to collect and process it.
Can she take that, and can you guys? Well, I guess you can't. Can you guys find I was going to say go into the library and start testing, but you can't get in the library.
Yeah, this coronavirus has really, put a heavy duty weight on us to try to just start setting stuff up, because we can't even go to school, and we've been trying to get access to some roof somewhere. And I think that for now, the best bet would be Engineering East, because we have access to Van Dam and some other professors, and maybe Engineering West if someone has a key for that. We can just set it up there, and just kind of collect some data using some remote software, and just kind of start small there.
Well, I'm wondering what you can do before August 20th. where can you put this up and start working on the software before school starts? Have you guys contacted any local buildings nearby?
I mean, I was honestly thinking if the weather isn't too bad, we could just go to the beach, and
Yeah.
there's a massive parking structure. There's a 5-floor parking structures, and we can get onto. I know some people who work there. I'm gonna see if maybe we can set it up on top of the elevator, because nobody can really go up there unless they actually try to go up there. And we can set it up right on top for a few hours just to collect a few, like a dozen or so satellite data dumps and work with that. But we're not going to be able to leave it there because, it can be stolen or destroyed or lost or something like that. So we have to go there for a few hours, get that, and then bring it back. So that's an option. And plus, we have a very open side towards the beach. This is, ocean. And then the other side is not really that many tall buildings for a few miles, uh, heading more inwards. And there's nothing really close by to the parking structure because that is the highest point in the
Okay. What
airport.
was that building that you said again?
I don't really know the name of it. It's just like if you take Hillsborough down to the beach on A1A, there's a parking structure there. It's by a breeze room and a few other places. There's no real name for it, I guess. Maybe it might be, I don't know it. It's a 5-story parking building. You take Hillsborough down to the beach.
Okay. Okay. Well, yeah, it might be worth it. You have to check to see if we can actually put something up there. But I mean, I guess if you're just sitting there with it above you, I guess it's
Yeah,
not
like
really.
if we're just sitting up there on the 5th floor, we can just set it up on the corner on like the railing, or we could get a little bit like a few feet higher if we set it up on top of the elevator. So it's a easy setup, and all we have to do is just kind of park there and pay the fee for, or just park somewhere else and walk up there. So.
Okay. All right. Well, yeah, it sounds like you guys definitely have a really busy next 20 days. But that's a good thing. We're gonna work on our end to try to get some funding in here pretty quick. So if we have a interview with COSO to get about $1,000 for funding. So if you have if you find another one of those ground stations like the one you're looking at here, that's maybe just a little bit more expensive, but does the same thing, and it's going to be easier to use. If you just find something that's similar, that's maybe a little bit better quality than what Sasha has, send it to me either by today or tomorrow, and we'll include it into our list for COSO to help pay for, and then that could be an early round.
If you want to start off with just a higher quality omnidirectional antenna it has a smaller cone of I guess reach or whatever, like of data collecting space, like a smaller degree, but it has a longer range and entire quality overall. If you want to start off with that, I think I saw some for like $150, give or take, maybe even less than that. You can start off with something like that.
Just
Or,
whichever you think is going to be the best bet. I just need an equipment list by tomorrow or today, and I'll present it and just try to make it as cost effective as you can, but maybe with a little bit better performance capabilities than what Sasha already has. If you can get me that by today or tomorrow, I might be able to get that for you from the university. Okay.
I mean, we could just do. We don't really need much else other than the antenna because all we're going to be doing is collecting data, right? So we don't need, for example, the only stuff we really truly need is the antenna and we have everything else. So just the skeleton. We're able to collect data now, but we just don't have a good antenna.
Okay. Well, I don't think we're going to be able to get a $687 $37 antenna right now with.
Oh no, I'm not talking about that. I'm talking about I'll find a cheaper one that has much better than the $30 one that we have right now.
Okay. Yeah, something in between maybe the XBot antennas or something a little bit cheaper than that, but something way better than the telescoping antenna that Sasha has right now.
Yeah.
If that's something that you can find, like I said, just send it to me and say like, hey, this is the one that we request, and then I'll talk to them about it. So it's really up to you. I'm not entirely knowledgeable in the transmitter receiving sector here. So whichever you do your research and you find out is going to be the best one, just say, hey, this is it, and I'll see what I can do. Okay.
All right, sounds good.
Okay. So over the next 20 days, in the next week, I need you guys to get me an antenna clarification and a finalized answer, because after those 7 days, there's no going back. So if you guys can get it to me by the 8th, this Saturday, so I need by August 8th, I need a definitive answer for the antenna. And with that, I mean like a plan for how to test it, how to make sure that it's going to meet the same specs as that $4,000 one, but for a cheaper price. I don't need a 3D model right now. For that, you can go to like GrabCAD or something like that and show other satellites antennas that have worked that they've built in house. But I need like a definitive plan. If you can build it for cheaper, a complete list of everything that you're going to need to do and the testing that's recommended that get done on it by the 8th, or if we actually have to go buy it for $4,000. That's what I need by the 8th. And then from now until the what time? What day does school start? The 20th, I think, or the 24th. Basically from
Yeah,
now.
something like that.
What's that?
Something like that.
Okay, so we'll say from now until the 18th, which will be the 17th, which will be a week before school starts. Try to get on top of the software. If you try to get on top of that software, get a good understanding of your ground station by then. And what I mean is like you know it pretty well, and there's nothing really new that you need to know for understanding how everything's going to work. And that's also going to include using the AGI software to understand everything about it. So, the next days, if you can get to me, what you don't know. So I think the best way we should go about doing this is write down, because I didn't see it in your presentation, your next steps. If you can write down your next steps for where you think your team needs to go, get that to me before the 8th as well. And then by the 17th, deliver all those things and how you got up to speed. So I need a next.
I mean, we're not going to have the licensing yet, because that's going to take, I think, 30 days to just have all that stuff. 30 or 90 days that we need to get all that stuff done. I don't remember exactly. It's based off of which licensing you get. But do you need that too by the 20th, or is it just the ground station setup and all that?
Well, you can't operate your software without the licensing, right?
We can't.
Technically, you're not allowed. I don't think you're allowed to use. I don't think you're allowed to use that antenna you bought without a license.
No, we can receive data. We don't need a license for that.
Okay, so then if that's the case, then receive all the data you can, and then just get the licensing before the 17th. Okay.
Yeah. The licensing is just so you don't mess up the satellites when you send out data.
Gotcha. Okay, so licensing and complete software knowledge of SatNogs by the 17th. And then by August 8th, I need a definitive answer for the antenna, as well as everything else that you feel your team needs to get caught up with. And then also by today or tomorrow, I need an antenna. I need an antenna for us to send in the presentation. Okay.
Okay. And you said it's going to be like around $1,000. Do you want to put all that $1,000 towards the antenna, or is that going to be total?
No, some of it's going to the wow factor, as we talked about yesterday. I think that they're going to go for about, I think $400 is going to go for that. I'm going to call Reese today, and I'll give you a definitive number for how much we can ask for the ground station. I don't know which is more important right now. So you tell me, is getting things for the ground station more important, or is getting the wow factor for the library more important?
Well, the wow factor I feel like is more important because we need the rooftop there. So the fact that
the library is not open.
It's not open to the public, just for students to go inside. But if we can, just have set up the wow factor and then have the recruiter just to go upstairs and set up
The
the
library is
demonstration.
completely closed. Nobody's staffing it. The building is empty.
Oh, really? Oh, man. So even when
It's
school
empty.
starts,
It's
there's
empty
no one
until
going to be
school
there?
starts. What's that?
So that's what I'm saying. So when school starts, is there going to be staff there? When school starts back up next semester?
When school starts back up on the 24th, it'll be open. But I'm talking the next 20 days.
Oh, yeah. No, I'm in the next 20 days, I can, to get the rooftop, we need to have access to the library, right? So I would say prioritize that. So then when it does
We're
open up,
prioritizing. Say that one more time. What are we prioritizing?
uh, the the library, so the wow factor, because if we have $600 left over and we don't need anything else other than we have the 400, we can actually just buy this straight out. But that's probably not the best bet. We can start off with just a higher end, of simpler antenna, maybe something like this, or maybe even cheaper.
Well, here's why I ask this,
Um,
because normally with the university, they don't give you everything that you request. They normally ask for a priority list. So in the event that we ask for everything that we need for the wow factor for the library, and then further down the list we have an antenna that's $600, they might just say, well, no, why are you spending $600 on an antenna? And then they go, well, it's a low priority for you, so obviously you were reaching for it, so we're not going to give it to you.
I
So
mean, that's the highest priority thing, the antenna.
so you need the antenna before you need things for the wow factor library.
I'm The thing with the antenna, we can buy a cheaper antenna. That's why I prefer to have the library, because that's like the best possible location to have the ground station, whether it be a better or worse antenna. You
So
know what I'm saying?
for the next 20 days, you don't need anything to be bought.
Well,
I'm
I
talking
want to test.
before the 24th, before school starts, from finals finishing now to before the library's open. You don't need any ground station equipment that's going to help you understand anything.
I want to get back to you on that because I want to test out the antenna at the beach at like a different location first to see if we're able to collect data in a better location.
How
Because if
soon can you get back to me?
probably is the end of the week okay, or
No,
earlier than that?
we have our presentation to request the funds on the 4th.
So are they just going to give us the money, or are they going to buy the stuff for us?
We have to demonstrate why we need the money. So we have to show them the list, and they go, okay, here. Well, they'll take the list, and then they'll analyze it, and then they'll vote on if they want to pay for it or not. But we can't send in amendments to that money. It's the 4th. The 4th, we have to have that list, and we basically just hand it to them, and they go, okay, we'll let you know. So we
Okay.
have 2 days.
So okay, I'll give you something by the end of the day.
Okay.
Antenna wise, to something in between those two and be like a little bit cheaper that we could use, and like something that we could use later on as well. And we'll still test out this antenna that we have right now to see if we can just use that, and then we can buy the other one whenever we can. Um, so I feel like that would be the best bet.
Okay.
And if anything, we can always just have two ground stations in two different locations as well.
Okay.
And we can use both antennas. And yeah, so I think we should focus putting because to set up the wow factor, we don't need nearly as much as the antenna, right? If we're going to get like the highest end antenna, and we could always buy something. If if you're going to give us up to $1,000, we can spend $300 to $400 on the wow factor, just with the display, the 3D prototype, the touchscreen on the Raspberry Pi, and the pedestal to put it on. So if that's an all cost around $300-400, we can use the rest of it to buy an antenna and possibly one other item.
Okay. Well, just do some deductive reasoning. Find out which is going to be the most which you can get the most of for a functioning ground station for whatever money is left over from how much we asked from the library deal. So if you can just get a list and say like, okay, well, I'll probably send you a text because I'm going to call Reese right after this call and have him calculate the total amount of cost he's requesting for the library. I'll send you that number and then just try to figure out, okay, well, here are my priority items. Here's how much money, that we have left to request. How much can I get of my priority items based off of this much money and still meet the requirements with NASA and, for our satellite transmission receiving capabilities. So if you can kind of figure that out and get that to me, please, before the 3rd at 11:59, because I don't want to have to make this presentation at midnight before before the day of our presentation. That would be really great.
Yeah, I can get the antenna information for you by the end of today or midday tomorrow.
Okay. All right. That sounds good. Stefano, do you have any comments or questions?
Yeah, the only thing I wanted to say is like, just, be prepared for the experimental licensing for the radio frequency, because on the CubeSat 101 it says like you have to fill out these 5 different forms, and they seem pretty long.
I was looking at that earlier.
Okay. I just wanted to make you aware.
We need to get the license ahead of time because they asked for some reference numbers and all that associated with that. So that stuff is gonna take some time to study for and then take the exam and then get the approval, get the licensing, and then apply for that. Because I think I already took about a month for that to go through the paperwork and all that. So that's gonna take some time to set it up. But that is for you need that to send out data send up data and commands to the to satellites. But collecting it, you can do, anybody can do it. You don't even have to have a ground station. You can maybe look at data from other ground stations, and that's all free as long as you make an account.
Well, NASA says that you should have all that licensing and everything on that filled out before we send in the proposal, because they want to see that there are people that are qualified and that they know how to communicate with the satellite because they have with other university CubeSats. So if you guys can get that paperwork sorted out and filled out and sent in before the 17th of August, that's kind of what we're looking for on our end for your team.
I mean, we can, without school, during the break, we can probably study and get the exam off the way, and then have the paperwork filled out and have it sent out. But it's going to take, it's probably going to take I don't know how much time, but we'll have at least the amateur radio license. And then the experimental license is going to take.
I'm not worried about how long it's going to take to get the licensing back. Well, I am, but that's going to be dependent upon how fast you guys can fill out the paperwork now. So if you guys can use the time to, like you said, with no school to fill it out, I'm not worried about can you get the licensing back by the 17th. We just need everything filled out and sent out because it takes so long, and we don't know how long it's going to take to get the paperwork back saying that we're qualified.
Okay, yeah.
Okay, so if you guys can get everything on your end done by the 17th for the licensing, and it's just well, there's nothing we can do except wait for the paperwork to come back, and that document that's in the CubeSat 101, those pages you have to fill out. You can just do all that by the 17th. That would be really great. Okay. All right. Well, I think that you have your work cut out for you and your team. We're gonna work on our end to get that stuff that you requested of us, and you got some dates down for your guys' end to meet. I'll look out for your text for the antenna later today. And nice job on the presentation, Anderson.
Real quick, do you have any idea of how we're going to get some more funding?
Yeah, we're going to get confirmation back from the IRS by, I think, this week or next week. I think if I have the timeline right, that we're going to be a 501c3, and we have a whole press release lined up for all of the local papers from, I think, Jensen Beach all the way down to Miami-Dade. Our social media manager is going to be sending out that press release as well. She's going to be sending it out to other businesses related to the aerospace field to basically say like, hey, come fund us. And then people are going to be donating money to our bank account, and that way we'll get money. That's what we have lined up right now. The university has said like, wait till the school starts because they need to figure out how much everything's going to cost, and they're going to get a whole bunch of money from students this semester. So.
Okay. And one last thing, do you have have you been talking to Van Dam?
No, Van Dam's out of his office until the 20th.
Okay, I don't know if you had like a personal email or number, because I was gonna ask maybe he had some old radio stuff from the radio club that we could possibly use.
Well, I'm just honestly shocked. If you guys were in such good communication, why would he just bail out on you and not tell you he's out till the 20th?
Well, emailing with him is always kind of a bit difficult because he tells us all the time that if he doesn't answer back in a few days, they know him again. Sometimes we have to do that, and didn't email him for like maybe 2 weeks because there was nothing like major we had to talk to him about. And then I tried to email him about some questions on the some of the collected data, and that was like a week and a half ago. He never replied. So and then he told me that he was
just because Van Dam's in his office, though, doesn't mean there might be some nearby people who have radios. I mean, you have all the radio club students who might know some people. You have
the radio club
Boy
doesn't
Scouts.
exist technically.
What's that?
The radio club doesn't technically exist anymore, and that's why I wanted to help him start it back up. That's why he has a bunch of stuff like old radio equipment left over from when it used to be so prevalent.
Right, but that's locked away in his office till the 20th. So I would say find local areas that have radios that they're using for certain things and see what you can do.
Yeah. Okay.
Okay. Alrighty. I'm gonna call it a meeting.
All right.
All right.